Hello, we are going to go ahead and do our last video for the energy unit, and it is talking about conduction, convection, and radiation. So let's go ahead and do an introduction to these. First of all, we control thermal energy transfers every single day from getting too hot or too cold. You know, we go inside if it's too hot outside. We adjust the thermostat on the inside if we're too cold. So we actually control thermal energy transfers every day. This is something we're already familiar with. And conduction, convection, and radiation are the ways energy is transferred. These are the three ways that we transfer that thermal energy from one thing to the other. Now let's talk about conduction. Conduction is the transfer of thermal energy by collisions between the particles that make up matter. You guys know that everything's made up of little particles, atoms, and molecules, and those collisions, those atoms and molecules hitting one another, that is actually how conduction happens. And it's the transfer of thermal energy through direct contact, through something that's actually touching something else. Now, when conduction occurs, more energetic particles collide with less energetic particles, and that's what actually caused the energy transfer. Okay, so let's talk about an example of this. If you leave a metal spoon in a pot of soup while it cooks on the stove, the spoon might get too hot to the touch. And as one of the end of the spoon heats up, the kinetic energy of the particles that make up that part of the spoon, they increase. They start moving more because the temperature has increased. These particles collide with neighboring particles, and the conduction transfers heat energy to the other end of the spoon as more particles with more kinetic energy transfer their kinetic energy to those particles with less kinetic energy. So conduction transfers thermal energy without transferring matter. Okay? Another example, if you touch something with your hand and it feels cool, that means that there is an energy transfer happening. And energy transfers always go from higher temperature to lower temperature, remember? So if my body's 98.6 degrees and the room is 70 degrees, that means the desk in the room is also 70 degrees. So if my hand touches it, heat is being transferred, heat energy is being transferred from my hand to the desk, and the kinetic energy of the particles in my hand are colliding with the ones in the desk to then do the energy transfer. Now let's talk about how fast things can conduct. And that all depends on the material. Conduction is faster in solids and liquids than in gases, and the reason is because in gases the particles are so far apart that collisions don't happen very often. So solids and liquids have conduction happen a lot quicker than it does in gases. Now when we say that we have a conductor, these are objects that conduct thermal energy very well, and the best conductors of thermal energy are metals. Now, insulators are the opposite of conductors, and those are objects that do not conduct thermal energy well. And examples of that would be plastics, rubber, styrofoam, wood, glass, etc. Now let's talk about convection. Convection is the transfer of thermal energy in a fluid by the movements of warmer and cooler fluids. Now fluids, when we talk about those, we're talking about liquids or gases. This does not occur in solids. This only occurs in liquids or gases. And when convection occurs, more energetic particles move from one place to another. And versus in conduction, they were colliding with one another. In convection, they move from one place to another. Now, most substances and fluids expand as their temperatures increase. So as the particles move faster, they tend to be further apart, which means they expand. And as things expand, their temperature increases. Remember, the faster the particles, the higher the temperature, and the faster they are and the further they are apart, the more expansion happens. When fluids expand, as their temperature increases, their density will also decrease, because as they expand, their volume increases, but their mass stays the same. And density is based on mass divided by volume. So if we increase volume, but mass stays the same, then their density decreases. This is what helps us understand the movement of air in a room, because the density of a warmer fluid is less than that of a cooler fluid. And because of that, that drives convection. The warmer portions of the fluid rise to the top of the fluid and the cooler portions sink to the bottom. This is why you want a top bunk during summer camp instead of a bottom bunk. I'm sorry, I said that backwards. That's why you want a bottom bunk in summer camp instead of a top bunk. Because hot air rises, cool air descends, and the reason is cool air is more dense and warm air is less dense. So it's going to rise and cool air is going to sink. Now let's talk about the last form of thermal energy transfer, and that's radiation. Radiation is the transfer of energy by electromagnetic waves such as light and microwaves. These waves can travel through space even when matter is not present. Radiation is the only type that can actually travel through outer space. Energy that is transferred by radiation is often called radiant energy. And an example are sun rays traveling towards the earth. Also, fire is an example of radiation transferring energy from the fire and increasing your thermal energy of your body. Now, I want you to go ahead and summarize tonight's video by telling me 2 new things that you learned in regards to thermal energy transfer, which includes conduction, convection, and radiation. I hope you have a good evening, and I'll see you in class.